This is section 5-4, and we're going to be talking about factoring polynomials. So the first way we're going to look at this is if we have a polynomial such as 6x squared y squared minus 2xy squared plus 6x cubed y. So factoring. So we want to pull out everything we can to simplify this polynomial. So here we have three terms. The first thing we want to do when we're factoring a polynomial is look for common factors first, the greatest common factor. So looking at this polynomial, we'll take each one of these terms and break it down. So looking at the 6x squared y squared, let's break it down into its base terms. So open parentheses. 6 is 2 times 3. X squared is x times x. And y squared is y times y. So we have open parentheses 2 times 3 times x times y times y inside of parentheses. Minus our second term, which is 2xy squared. In open parentheses, after our minus sign, we can't break that 2 down any further, so it's just 2 times x times y, close parentheses. And last but not least, we have this plus 6x cubed y. So plus, open, 2 times 3 times x times x times y, close parentheses. Okay, so what is the greatest common factor? First, let's look at our coefficient. What number is in each one of these terms? So we have a 2 in each one. We have 2 and 2 and 2. We have an x in each one, and we have y's. So let's first look at this. Let's do 2 times xy. We can get 2 times xy out of each one of these because we have 2 x's, 2 y's in our first term. We have 1 x in our second, 2 y's. And the third ones, we have 3 x's and 1 y. So what we have in common, each one has at least 1 x. Each one has at least 1 y. So that is our common term. So how we write this is looking at our first term, 2 times 3 times x times y times y. Let's pull out that common term of 2xy. So we have open parentheses, 2xy, close parentheses, open, and whatever's left goes in the second set of parentheses. So the first one we have a times 3. So then we have 3, and we have 2 x's, and we already pulled one out. So we have x. And then the last part, we have y times y. Well, we pulled that other y out when we were factoring. We decided that was our greatest common factor. So then we times that by y. So what do we have? Open 2xy, close, open 3xy, close. When we multiply that all together, we get our original term, 6x squared y squared. Okay, minus. Okay, we decided our common term is 2xy. So after the minus sign, we have open, 2xy, close, open. So the second term is 2 times x times y times y. So all we have left in this middle term is just 1 y. We pulled everything else out for our greatest common factor. So we have open parentheses y close. So our second term then becomes open 2xy closed times y. Plus, now, the last one, we have 2 times 3 times x times x times y. Greatest common factor, which we pulled out, is 2xy again. So that's inside parentheses times what's ever left in this last term. So we have a 3, and we have an x squared because we still have 2 of those left over, and no y's because we used the 1 y in our greatest common factor we already pulled out. Okay, so now how do we regroup this? what we do is we take this 2xy and put it on the left. So I've opened parentheses 2xy, because that's a common factor for each term. And we then multiply it we multiply this open 2xy closed to everything that is left in each term. And the way this looks is we have open 2xy closed, open, the first term we still have that 3xy. The second term we have 2xy times y, so then we just do the minus y. And the last we have plus 3x squared. Close. So we factored out of each one of these terms a 2xy. So what we're left with is open 2xy close, open 3xy minus y plus 3x squared. And that's as far as we can go for factoring out using the greatest common factor. Okay, now example 2 on page 240. Let's talk about factoring using grouping. Okay, so if we have a cubed minus 4a squared plus 3a minus 12. We want to look at this in terms of how can we group these in together to pull out the most factors. So we can rearrange these using the commutative property to find how we want to group them. So let's start by grouping them just as it is. So we have open parentheses a cubed minus 4a squared close parentheses plus open 3a minus 12 close parentheses. So let's look at what we can pull out of each one of these. We have a cubed minus 4a squared. Coefficients we can't do anything with because we have a 1 and we have a minus 4. But we have an a cubed and an a squared. So we can pull out two a's because the greatest common factor they have is a squared. So this would look like a squared open. So a squared, when we pull out a cubed, when we pull out a squared, we're left with just a minus 4. Close parentheses, because the a squared we can pull out all the way. Now if you were to multiply that back through, you'd end up back with a cubed minus 4a squared. Okay, that's the first term. So we have a squared open, a minus 4 closed, plus, now we're going to factor this second grouping, the second term. We have open 3a minus 12. Well, we can't pull any a's out because the second term doesn't have any variables. But 3 is a factor of both 3a and 12. So we can pull a 3 out. So then we have 3 open, a minus 4 close. And if you notice, what's inside of the parentheses, we have a squared open, a minus 4 plus 3 open, a minus 4. And since those two terms both have that a minus 4, we can then, using the distributive property, we can multiply through, and what we end up with is a squared plus 3 in parentheses times a minus 4. Since we have that a minus 4 on each of these terms, we can just group them together, take what we're multiplying in front of this, and multiply them all together, which means open a squared plus 3 close, open a minus 4 close. Now, how do we know that works? Well, let's multiply it through and see. Using our FOIL method, a squared times a is a cubed. That's the front. Now the outer, a squared times minus 4 is minus 4a squared. Inner terms, 3 times a is plus 3a. And the last term is 3 times negative 4, minus 12. Okay, so it works. If you look at our original equation, we had a cubed minus 4a squared plus 3a minus 12. So the point of factoring is breaking it down to the most basic terms.